Okay. All right, we're going to go ahead and start working through some problems. So this problem just says Anderson's Bank uses the banker's rule to compute interest earning 4.1% compounded daily. And Jones Bank uses simple interest at 4.19%. So if Anderson and Jones decide to deposit $14.50 into a joint account, calculate how much they would have in each account after 2 years, and then use this to decide which bank should they use. So we're basically going to do this separately for each bank. Let's start with Anderson. So for Anderson's Bank, it said banker's rule. Banker's rule generally means that they're going to use 360-day per year calendar. So this would tell us that N in this case is 360. Any other time that it said that it's compounded daily, we would actually use 365, banker's rule. This says it's computing interest at 4.1%, and R value of 0.041. And we know in this case we are putting $14.50 as our principal, and this is for a time period of 2 years. So based on this information, the fact that there is no payment amount and that it talks about compounding interest, I would use our compound interest formula. So I would use this A equals P times 1 plus RT. I'm sorry, that's for simple interest. One, compound interest. So substituting in our values here, we would get 1450 times 1 plus 0.041 over 360. And we raise that to the 360 times 2 power. I'd substitute that into the calculator. When you put this in the calculator, if you put it in all at once, you would want to put an extra parentheses around that exponent. And we should get $1,573.90 if we round that to the nearest cent. All right, so then let's do this for Jones Bank to compare. So for Jones Bank, she's still depositing the same amount. So that's still the principal. On hers, it says that it uses simple interest, and the interest rate is 4.19%. So this would be R equals 0.0419. It is also still for 2 years. So I'm going to use, in this case, since it's simple interest, I'm going to use my future value for simple interest formula. I plugged in our principal, 0.0419 for the rate times 2 years. And in this case, we get close to the same amount, $1,570.51. So we can see in this case, they're pretty similar, but we would say that Anderson's gives just a little bit more money. So Anderson's would be a better choice in this case. Any questions or comments on this one? So the next problem that I chose here is it just says to complete number one again, but this time by finding the effective rate of interest for Anderson's Bank. So effective rate of interest is basically saying for a compound interest problem, what would be the equivalent simple interest rate for 1 year? So even though it's compound interest, we're saying it's equivalent. So we already know for Jones Bank, hers was at simple interest of 4.19%. So we want to figure out Anderson's Bank would be equivalent to what simple interest rate if it were only for 1 year. So we're going to get some practice then with the effective rate of interest formula. So using this formula. So for Anderson's Bank again, remember that the rate was 4.1% or 0.041. And this used the banker's rule. So we're using 360. Place of N. So if I put that into my calculator, I'm going to get a really big decimal. So this is giving me 0.04184967. It keeps going past that, depending on how many digits your calculator shows. So when we give the answer for effective rate of interest problems, we want to make sure that we change it to a percent. And you want to make sure you change it to a percent before you round it. So you don't want to round it. In this case, it says round it to the nearest thousandth of a percent, but you don't want to round it first and then change to a percent. You want to change it to a percent first. So to change to a percent, we would just move that decimal 2 spaces. So this is going to be 4.184967, keeps going percent, and then round it to the nearest thousandth. So thousandth place would be the 4, since there's a 9 behind that. This would be 4.185%. So if it was just for 1 year, we can see that Anderson's Bank would be equivalent to offering a simple interest rate of 4.185%, which again is really close to Jones Bank at 4.19%. So very, very similar. But you can see in this case, Jones is actually better. So if it were just for 1 year, Jones is ever so slightly better. So we could say something along the lines here, this is not as good as Jones interest rate, even though they're very close. That's only if you consider the fact that it's only for 1 year. So anytime we find the effective interest rate, it's just an annual interest rate. So in number 1, we saw that actually over 2 years, Anderson's was the better choice. Questions or comments? Anything on, since these are 2 related problems, anything on these first 2 problems? All right, so we're going to continue to look at just some example problems and things you might see from the financial sections. A lot of what's tough about these problems is deciding what formula to use when. We've got our formula sheet, we've got lots of stuff to choose from here. So like, how do you know which formula to use for what problem? Typically, if it's a simple interest problem, it will typically say that. It'll say something about simple interest. What can really be tough is knowing the difference between compound interest and annuity problems, because both annuities and compound interest problems technically have compounding as part of that process. So the big difference, the way that you can tell whether you should be using one of the annuity formulas or whether you should be using just a compound interest formula is there a payment, right? With annuities, we're saying that there is a payment amount. There's a regular amount that you are putting in, that you're depositing, or it could be that you're taking out, depending on the problem. So if there's a payment amount, that's typically not going to be just compound interest. And if there's not a payment amount, if there's just some initial amount of money, then we would say it's probably going to be a compound interest problem. So we'll kind of keep that in mind as we look through these. On this one, it says if a $28,000 car is financed for 48 months at 0.8% after a 10% down payment, calculate the monthly payment, the total installment price, and the finance charge. So we have a lot to calculate on this one. What I would start with is really any of these problems is I would start by just underlining my numbers and putting labels with them. That's a good way to go and to kind of help you figure out what formula to use when. So in this case, I know that $28,000 is the amount of the car that I want to finance, that I want to take out a loan for. Typically, that means that would be my principal. That's the starting amount of my loan, unless there's a down payment. And in this case, there is. So this says after a 10% down payment. So I might go ahead and while I'm doing this, I might go ahead and just figure out how much that down payment is for. So 10% of 28,000, I would just do 0.10 times 28,000. And that would give me a down payment of 2,800. Which means that my principal, or the amount that I'm borrowing, is not going to be the full 28,000. It's going to be however much is left after I make that down payment. So I'm going to take the $28,000 price of the car, subtract my down payment amount, and then that difference is going to be the amount that I need to borrow, the amount financed. In this case, it's going to be $25,200. So that's going to be my principal in this case. So I kind of got off track there, but that's okay. Like kind of working through this a little by little. So we have a $28,000 car. We figured out that after the down payment, that means the amount we're borrowing, or the amount financed, is $25,200. If we keep reading this, we can see that we're financing this for 48 months. And then this does talk about, if we look ahead, it's talking about a monthly payment. So I do know that like the number of payments is going to be 48. In terms of my formulas, I know that that means, so 48 months, if there's 12 months in a year, 48 divided by 12 would give me 4. So that means that T in this case is 4 years. My time is always in years. One of the credit card problems, your time is always time in years. And then I also know, since this is monthly, I could also say that that means that N equals 12. So I've already found a lot of information. I know P, I know T, I know N. It says 0.8%. So R would be, if I move that decimal 2 spaces, that would be 0.008. I've kind of boxed in like all the important stuff that I found from this. So I'm just going to take this one at a time. It wants me to find several different things. The first thing here says to calculate the monthly payment. So I already know that this has to do with a loan. I know that I'm trying to find the payment amount. So if I look back at my formula sheet, there is a formula on there for loan payment, right? So the last one on our formula sheet. So it makes sense that that's the one I would use. So I'm just going to copy down that formula. So then our capital R is going to stand for our payment amount. That's what we're trying to find. So I could just go ahead and substitute the values I have here. So 25,200 in the place of P. 008 for little r, This is monthly, so in this 12. 1 minus 1 plus 0.008 over 12 raised to the negative 12 times 4 power. Or if you didn't do negative 12 times 4, you could go ahead and say, okay, we knew it was 48 payments. And you could go ahead and just say negative 48 there. That's fine. Any questions to this point, just on how we're getting any of these values or where we put them in the formula?
It's good.
So all that remains really, at least for this part of the problem, is just to put this in the calculator. If you're putting this in the calculator all at once, remember that anytime you have more than one thing in a numerator, denominator, or exponent, you need to put an extra parentheses around that when you put it in your TI-30 XIIS calculator. So in this case, so again, numerator, denominator, exponent. So I would put an extra, sorry, I didn't mean to erase. I would put an extra parentheses around my whole numerator, an extra parentheses around the whole denominator, and then also an extra parentheses around that exponent, that negative 12 times 4. So that's how I would need to put this in the calculator. Also, remember on the TI-30 calculator, when you put in your exponent, negative 12 times 4, make sure you use the negative button and not the minus sign, because it will give you an error message if you use the minus instead of a negative. So in this case, when we put this in, we should be getting an answer of, should be getting $533.62. That is our payment amount. Any questions, or if anyone's not getting that same answer, I can come help. All right, so this one, I did ask for several things. So far we've got one of them. We found the monthly payment. So we are good on that. The next thing it asks for is the total installment price. The total installment price is basically everything that you're going to pay over the whole time that you pay this loan back. So we did calculate the payment amount. The payment factors in both paying back what you borrowed and paying the interest on that. So the payment already figures both of those numbers in. So really, if I want to find the total amount that I'm paying, I really just need to figure out the total of my payments, and then also factor in the down payment. So the total of my payments here, I'm making 48 payments, right? Since I'm doing this monthly payment of $533.62 is my monthly payment amount. I'm doing that every month for 12 months per year. I'm doing that for 4 years. So times 12 times 4, or you could just say times, instead of 12 times 4, you could just say times 48, since that's 48 months that you're going to make payments for. If I do that, if I do $533.62 times 48, that's going to give me a total amount of $25,613.76. So that's what I'm going to pay back over the 48 months of this loan. But remember, we also make a down payment. So if I want to find the total of everything paid, I would need to add to that number remember we calculated before, the $2,800 down payment. So I would add my down payment amount to that as well. So that's going to give me a total installment price $28,413.76. And it makes sense that that's a little bit more than $28,000 because we should be paying interest on that. So we're paying back what we borrowed plus interest.
I have a question.
Mhm.
Would they ever ask that in a way where you would not include the down payment?
They could ask you for the total amount of the payments.
Okay.
So if they asked it that way, if they said, what's the total amount that you would pay back on your loan? Then I would not add the down payment back in with that.
Okay.
Good question. All right, so that's our total installment price. And then the last thing we need to find is the finance charge. So the finance charge, remember, whenever it asks for finance charge, that's the same thing as interest, right? That's all at once here. And so to find the finance charge or the interest here, anything that you pay that is more than what something is worth, interest, right? So we're paying $28,413.76. And that was what we were paying for a car that was worth $28,000. So whatever that difference is how much interest you're paying. In this case, it's not too bad because we had a pretty low interest rate, 0.8%. So we end up getting a finance charge or interest amount of $413.76. Any questions or comments? All right, so let's take a look at the next problem on my list here. If you deposited $4,100 at 0.6% interest compounded quarterly, how much interest was earned in 8 years? So again, the main thing here is to figure out what formula do I need to use. And so I'm gonna approach this by just first putting labels with things. So I can see in this case, I deposited $4,100. So that is my starting amount of money, right? I'm starting with a principal of $4,100. I can see 0.6% is my interest rate. So if I move the decimal 2 spaces, I can see that that's an R value of 0.006. Interest is compounded quarterly. So that means N is 4. And then it wants to know how much interest was earned in 8 years. So T would be 8 in this case. So in terms of deciding what formula to use, I know it does mention compounded, so I know it's not going to be a simple interest formula. But how do I know whether this should just be the compound interest formula or if this should be an annuity formula? There was no payment amount mentioned, right? This never mentioned like putting in an amount every so often. Like it didn't say I was going to deposit this much money every quarter. It just said I was going to start out by depositing $4,100. And then I want to see how much I'm going to earn in 8 years. So this would just be my compound interest formula. I would not use one of the annuity formulas here. All right, so substituting values in 4,100 times 1 plus 0.006 over 4 to the 4 times 8 power. If you put this in your calculator all at once, again, don't forget to put an extra parentheses around your exponent. Or in this case, you could probably say, hey, I know 4 times 8 is 32. And in that case, you can put it in 32. But if you do put it in as 4 times 8, stick that extra parentheses in there. And if we think about this, like in terms of what answer we should get, like what answer is reasonable here, we're finding A. A stands for the future value. So that would mean I'm looking for what amount of money I'm going to end up with. If I'm investing 4,100, I should end up with a little bit more than that, right? So if I got an answer of say like $500, I could rule that out and say that's not reasonable, right? I should end up with more than that. Versus if I got an answer of $100,000, that's really, really big. So I'm probably not gonna invest 4,100 and end up with 100,000. So I would expect, you know, reasonable answers, maybe 5,000, maybe 4,500, something like that. In this case, we should get $4,301.44 when we round it to the next cent. Questions here? I have a question, and that is this what they asked for?
No.
No. So this is where you can do everything right and then not realize that you don't have the right answer to a question on your test. So it would be really good to just remind yourself, maybe even write it at the top of your test, say, check and see, did I answer what they asked for? Because on this one, we've done everything right, but it asked us how much interest was earned in 8 years. And what we just found is the future value, right? So it didn't ask us for the future value. It didn't ask us for the balance in 8 years. It just wants to know the interest. So we just have an extra step to do here, but it's easy to miss that step. So all I need to do is just say, okay, I started out with 4,100. I ended up with 4,301.44. However much more I have in the end than what I started with, that's my interest. So to find the interest, which is what they asked for, I just need to subtract those two numbers. It's real easy to forget that step and not realize what they asked for here. So this should be $201.44. Any questions or comments? Anything on any problem so far? All right, so then let's look at the next one. So this one says, we're doing a mortgage problem. It says if you want to keep your mortgage payment at around $750 per month, and you get a 30-year mortgage with an APR, which stands for average annual percentage rate of 2.95%. How much money could you borrow in order to purchase a home? And it wants it to the nearest whole dollar. So I know this is talking about a mortgage payment. So that makes me think it might be the payment formula, but I would go ahead and I would start putting some labels on things just to be sure of that. I think what a lot of people tend to do is they tend to see that dollar amount and they automatically think that, oh, that's P or that's A, right? It's really important to pay attention to, is that our starting amount of money? Is that our ending amount of money? Or is that our payment amount, right? In this case, it says we want to keep our mortgage payment at around $750 per month. So that's a payment amount. So this is not P and it's not A. This is capital R, because that's a payment amount in this case, which is helpful because if I flip to my formula sheet again, so there are only 3 formulas on here that have a capital R in them, and those are the last 3. So at least just knowing that, if I can correctly identify a capital R, then I know it's got to be one of those bottom 3 formulas. So then let's keep reading. So let's see. 30-year mortgage. Well, 30 then is the number of years. That's T. The APR is 2.95%. So that's lowercase r 0.0295. And that's all they give me. So then what do they ask me to find? They say, how much money could you borrow in order to purchase a home? This is kind of working backwards. It's giving me the payment amount, $750, and it wants me to figure out how much money could I borrow. So that's my starting amount. That is the principal on the loan. How much am I actually going to borrow? So I'm going to have to kind of work backwards here to find P. So if I look back at my formula sheet again, so I've got it narrowed down to these bottom 3 formulas. Just the fact that I know I'm looking for P, there's only one of these formulas that has a P in it, and that is the loan payment formula. And that's the one that I mentioned was suspected at the beginning, right? So we were saying this is a payment, right? We have a payment. And in this case, it is a loan because it's a home loan, it's a mortgage, right? So I'm gonna use that formula, that loan payment formula here. All right, but this looks a little bit different. So it's important to write down all parts of your formula because I'm not plugging 750 in for P, I'm plugging 750 in for R. And so I would just leave P in my formula for right now and plug in everything else. This is gonna be 0.0295 over, let's see, did they tell me N? They didn't tell me N. So typically they will tell you what N is, but if it's a mortgage problem, if they don't tell you that it's something else, typically mortgages are monthly. So just the fact that it's a mortgage problem here. Oh, it does say per month, right? So that would tell me that N is 12. Even if it didn't say per month, typically we assume mortgages are monthly. All right, so at this point, the rest of this is just going to be putting this in the calculator. Before we do that, any questions to this point? So what I would do in order to put this in the calculator. So what I'm going to do to put this in the calculator is I'm going to go ahead and I'm going to do this part of the formula. So basically everything except for the P. So when I put that in the calculator, remember to put those extra parentheses. So I've already got a parentheses around the numerator, but I would want an extra parentheses around the denominator and around the exponent. So I'm going to put that in the calculator. I'm going to get 750 equals P times. So when I put that whole part, everything but the P on the right side there, when I put that in the calculator, I'm going to get this big decimal. It's going to be 0.004189. Let's see if I can read my own writing. 12199. This thing keeps going, right? Real big decimal. So then I want to solve this equation for P. I want to get P by itself. So the way that I would do that is I would divide both sides by that number. So when I divide both sides by that big long decimal here, on the right-hand side, it's going to cancel and just leave me with P. And so then on the left-hand side, I'm going to do 750 divided by that. So one way you can do that is just the way I've shown it here, and write down as many decimals as it gives you, and then do 750 divided by and divide by all of those decimals. If you write down all the decimals, then theoretically you should not have rounding error. If you want to avoid any chance of rounding error though, remember that there is the ANS button on your TI-30 calculator. So if you do 750 divided by, and then the ANS button, which is second, and then the negative button. That would divide by whatever the previous answer that your calculator had. So as long as you had that 0.00418, that whole thing in your calculator, then you can just do 750 divided by that. So we should be getting on this one. It said to round to the nearest whole dollar, so $179,035 is what I got. So that is the price of the home that we could afford. It doesn't mention anything about a down payment here, so you don't have to worry about that on this one. So without worrying about a down payment, we say if we want to keep our payment at 750, we can afford a house worth around 179,000. Any questions on this working backwards process or anything on that problem? All right, so I've got an example here of an average daily balance problem with a credit card. So I can see in this case, it says Nancy's credit card charges 1.1% monthly interest. Honestly, for a credit card, that's kind of a low interest rate. So using the average daily balance method, this is her statement for November. So you can see it lists her previous balance. So at the start of November, she owed $1,212.30. She did use the credit card in November. You can see on November 3rd, she charged a birthday gift in the amount of $74.35. So keep in mind that on a credit card, the balance is not like the balance on your checking account. It's not money you have, it's money you owe, right? So when we make a charge, when we spend money, that actually makes the balance go up, not down, right? Because we already owe $1,212.30, and then we're gonna make additional charges on top of that. And then we can see that on November 8th, we made a payment. So we paid $250. So it shows that in red negative. So we could subtract that from our balance. And then we used the credit card again on November 28th, and we charged an oil change, right? And then this one, it says that the billing date was November 1st and the end of the billing period was November 30th. So for the whole month of November, this is our transactions. So it wants us to calculate the average daily balance, and then also the finance charge and the new balance on December 1st. So at the beginning of the next month, what's the new balance? So there's several ways to approach this, but I like to use a table. I think a table is really handy to do average daily balance. So what I'm going to do is I'm going to make a table. I'm going to put the dates along the top. So I'm just going to start with the first of the month, November 1st. And I'm going to put all the transaction dates on here. So I can see November 1st was the beginning of the month. There was a charge made on the 3rd. So I'm going to put that date on here. There was a payment made on the 8th. And then I also used the credit card on the 28th. So those are the dates I'm going to put in. And then I'm gonna put in a line to want the balance on each of those dates. I'm gonna want the number of days that it stated that balance. And then we're gonna multiply those. We're gonna find the product of this. So let's just start filling out the table with the balance on November 1st. So on November 1st, the balance was the $1,212.30. And then on November 3rd, that's when that amount will change. So we charged a birthday gift, $74.35. So that would increase our balance due. So we would add the $1,212.30 with that charge for $74.35. And so starting on November 3rd, my new balance would now be a little bit higher. This is $1,286.65. So then it would stay at that balance until the next thing comes through. So payment on November 8th. So then to that number, we would subtract $250. for making a payment that would cause my balance to go down. So on November 8th, my new balance is $1,036.65. And then the last thing is November 28th. So we made an oil change, we got an oil change, so we charged $65.30, so I would add that, add the $65.30, and that means my balance at the end of the month is $1,101.95. Any questions just on the setup of the table or how we got any of those numbers? So then I want to know how many days did it stay at that balance? So we know on November 1st, we started out with this balance of $1,200.30. And then it would have stayed at that balance for November 1st and November 2nd. And then on November 3rd is when it changed. So it stayed at that balance for 2 days. So it was at that balance for 2 days. Then on November 3rd, the balance changed to $1,286.65. And then it stayed at that until the 8th when we made a payment. So that would be for how many days?
5 days.
5 days. So that would be the 3rd, 4th, 5th, 6th, and 7th, right? So then it changed on the 8th. And then it stayed at that until the 28th, right? So that would be 20 days from the 8th through the 27th, right? And then that last balance, so it changed on November 28th. And so this would depend on how many days are in your month. In this case, there's 30 days in November, but that could be different if we're talking about like December has 31 days. So since there's 30 days in November, this would stay at that balance for the 28th, 29th, and 30th. 30 days, that balance. So from this information, like from finding the balance throughout the month, what we want to do is we want to find what's the average daily balance. So how do we find an average? We add them all up and divide by how many there are, right? So I essentially want to like just add up my balance. I'm going to write this here and then I'm going to erase it. So I would say, okay, day 1, November 1st, that's my balance. Day 2, November 2nd, that's my balance, right? Day 3, here's my balance. Day 4, that's the balance again, because it stayed at that balance for 5 days. So I would just keep doing this, right? But there's a faster way. So the faster way is to say, well, instead of adding this for November 1st and November 2nd, we're just multiplying by 2 because it stayed at that for 2 days. So that's why I'm going to find the product here, right? So I'm going to multiply those two numbers together. In this case, I'm getting $2,424.60. And then same thing with this. So instead of adding $1,286.65 5 times, I'll just do 5 times that number. So I'm essentially just adding this up by finding the products first. All right, so it's $1,286.65 plus 5 would give me $6,433.25. Then instead of adding $1,036.65 20 times, I'm just going to do that times 20. That should give me $20,733. And then $1,101.95 times 3 gives me $3,305.85. Checking on that. Any questions on those or make it different? So if those are right, then the next thing is just to add all those up. So I'm just gonna find the sum of those products. So I'm gonna add that last row, 2,424.60 plus 6,433.25 plus just add that whole last row. $1,096.70. Now wait for a second here and let everybody catch up and check me and make sure I didn't make a mistake here. And the total number of days in November is 30. So we said the way we find an average is we add them all up and divide by how many there are. So we're going to take that sum, the 32,896.70, and divide it by 30 days in November. And that's going to give us our average daily balance. In terms of what's typical, you know, my balances range anywhere from 1,286.65 to 1,036.65. So it should be somewhere in there. So if you get anything outside the, you know, 1,000 something to 1,200 something, you know, it's probably not right. We got $1,096.56 if I round it. All right, so that's our average daily balance. They also asked us for the finance charge and the new balance on December 1st. So we're going to find that as well. So the finance charge, remember, that's just another name for interest. Credit cards use simple interest. But what's different about credit cards is that instead of the rate and the term R&T, instead of them being annual, they are monthly. So R is our monthly interest rate and T is the time in months. So since we're using the average daily balance method, we're going to use that average daily balance, 1,096.56 is our principal. And then, let's see, they must have told us the rate here somewhere. Up here. 1.1%, and that is the monthly interest rate. So 0.011. And then T is the time in months. This is just 1 month. This is just the month of November. So just times 1. $1,096.56 times 0.011 times 1. So the interest in this case, if I round it to the nearest cent, is going to be $12.06. Honestly, for a credit card, that's not too bad. All right, and then the last thing they asked us to find here is the new balance on December 1st. So basically, all we need to do to do this is just find what was the old balance and then add the interest to it. They're going to charge us this $12.06 interest. So the most common misconception or common mistake I'll see here is that people will take that average daily balance, 1,096.56. They'll take that number and they will add the 1206 to that. But that number is not our, this is not our last balance, right? That was the average daily balance. That was the balance on average. The last balance was this one on November 28th, the one through the end of the month. So to find this, we're going to take the previous balance, $1,101.95, and add the $12.06 interest to that. We add $12.06, and this should give us the new balance of $114.01. Okay, any questions? Okay. All right, so let's take a look at the next problem here. It says, suppose that you start a 401k plan when you turn 25. And you contribute $2,400 at the end of each year until you turn 65 and retire. Suppose that your contributions go into a long-term investment that returns a steady 8.75% annual interest. We want to know how much will be in your fund at retirement to the nearest whole dollar. So first of all, I want to mention this 401k. That is not a number in our problem, right? So a 401k, that is the name for the most common type of retirement plan that you would get through your employer. So that is not, we're not saying 401,000 is the amount of money that we're using. So this is called a 401k. And I'll give you another hint here. Typically, if it mentions 401k, 99% of the time, it's an annuity problem because retirement is annuity. So sometimes you'll get lucky with that. Sometimes it'll say something like 401k, and that can be your clue to use one of the annuity formulas. Sometimes you might even use the word annuity, in which case count yourself lucky. So I'm already thinking like pretty darn sure this is going to be one of the annuity formulas, but we'll go through and we'll kind of label things to be sure. So again, 401k, that's not like a number that I'm using. It does say when I turn 25. So that doesn't really like give me a value, but this is talking about when I turn 25 and I do it until I turn 65. So it doesn't give me the number of years, but I could calculate that pretty easily. So T would be 65 minus 25 would mean that this is over 40 years that I'm investing in my retirement. And that takes care of the 25 and the 65. What about the 2,400? So is that a starting amount of money that I'm putting in and seeing how much it ends up as? Is that a payment amount that I'm putting in every so often? Is that a future value that I'm talking about ending up with that number? So in this case, it says I'm going to contribute 2,400 at the end of each year, right? That's your clue. So the fact that I'm doing this at the end of each year means that's not just a starting amount, that's a principal, that's a payment amount, right? So that is capital R. So then what else do I have here? 8.75% annual interest. So R would be 0.0875. I think from that, we may have everything we need. So this is asking me how much will be in our fund at retirement. So basically, how much are we going to end up with? So I'm trying to find the future value in this case. So the fact that there's a payment, and as I said before, the fact that they mentioned 401k was a big hint. The fact that it's a payment and it has a 401k, this is going to be one of those two annuity formulas. How do I know which one? Technically, either one works. So if you mess up on that, you can still get the right answer as long as you plug everything in the right spot and solve for the right variable. But on this one, they did want the future value. They wanted to find A. So I would go ahead and use the future value. That is the tough part with these, is just deciding like what formula do I use? All right, so I can start substituting things in my formula, 2,400 in the place of capital R. 0875 for lowercase r. N, tell us N. Yeah, they said annual, yeah, so this said at the end of each year, right? So we would just use 1 then for N. We calculated this was for 40 years, since it's from the time we turn 25 to the time we turn 65. And then the rest is just putting this into the calculator. So if you put it in the calculator all at once, again, remember those extra parentheses. So exponent, numerator, your denominator. You could probably get away with some of that on this one since we're just using 1 for N. So like 1 times 40 is just 40. You could probably get away without putting that in parentheses. And the same thing, like 0.0875 divided by 1 is just 0.0875. So you could probably get away with simplifying this a little bit. But if you didn't, it doesn't hurt it. Either way. So in terms of like what kind of answer would be typical here, we're investing $2,400 each year for 40 years. And this is a decent interest rate to be investing that at. So I would expect a really big amount of money. We're talking about you're going to want to retire on this amount. So if you're getting something like, you know, $5,000 or $10,000, I would maybe check your answer, see if you get something else if you do it again. I'm getting to the nearest whole dollar. This is $758,483. Getting something different, let me know and I'll help you, or any questions there.
Because I'm iPhoning it. I'm getting close.
Questions, comments? Okay. The next one is an amortization schedule. So full amortization schedule would be like pages and pages long, because it would be basically a schedule of for every single payment that you make on your mortgage for the whole, if you're talking about a 30-year mortgage for the whole 30 years, how much of your payment went to interest and how much went towards the principal. We're only going to do a few lines. So in this case, we just have 3 lines to do. So in this case, Shannon qualified for a 30-year, $119,900 mortgage at 3.4% with monthly payments of $532. So we're going to do the first 3 months. So since we're doing this month by month, we can just do this with a simple interest formula.
Yeah, not only.
So I equals PRT. And so we're just going to do this a month at a time. So for month number 1, for the very first payment that we make, the principal would be how much money we borrowed, right? So we had a $119,900 mortgage. Our interest rate is 3.4%, so 0.034. And then we're back to T being time in years, but since this is only for 1 month, it's just going to be 1/12 of a year. Let's do that. 119,900 times 0.034 times 1/12. So for the first month only, you can see the interest is $339.72. I'm gonna fill out this table a row at a time. So the next thing I want to fill out is the payment on the principal. So $532, that's my payment amount. $339.72 of that is interest. So that means the payment on my principal would be the difference in those two numbers. 532 minus 339.72 is going to give me $192.08. So of my $532 payment in that first month, $339.72 is going to interest. Only $192.28 is going to paying off what I owe. So then what's the new balance on the loan? Well, I started out owing $119,900. After the interest, I was only able to pay off $192.28 on the principal. So my new balance here is not much lower, $119,707.72. First line, okay, any questions there?
I'm giggling. That feels like my student loan payment.
All right, so then we're just gonna repeat this process for each row of this table. So moving on to the next one, if I wanna find the interest there, I'm gonna do the same thing. I'm gonna use this simple interest formula. But now my principal is the new balance, right? So this is gonna be the $119,707.72. And then I'm still gonna multiply that by 0.034. And this is still just for 1 month, the second month. So this would be 1/12 of a year. So what should happen there is that as I make payments on my mortgage, less and less of it is interest, very, very slowly. So I would expect that my answer here is going to be pretty close to the $339.72, just maybe slightly less than that, right? So as we pay off our loans, less and less is having to go towards interest and more is going to paying off the principal, paying off what was borrowed. But it's very slow. In this case, I got $339.17. So then again, I would take, my payment was $532, subtract how much of that went to interest. And that would give me how much went to the principal, which again should be just ever so slightly more than it was last time. This time I'm getting $192.83. And then we would take that previous balance, the $119,707.72, and subtract what we were able to pay down on the principal. So very, very slowly, I should see the balance on my loan go down. Questions on that second line? All right, let's just do the third line then. So the new balance, the new principal, $119,514.89. Same interest rate, 0.034. This is still for just 1 month, so 1/12 of a year. Getting $338.63. Subtract that from the $532 payment. At $193.87. you were to do this for all, 360 lines of your mortgage for all 360 payments, by the time you get to the end of your payments, most of what you're paying would be paying on the principal. Very little would be paying in interest. And then we'll take the old balance, the 119,514.89, and subtract that 193.37. $118,321.52. Definitely be discouraging at first though, because over the first 3 months of payments, we've managed to pay off, less than $400 of what we owe, even though our payments are $532 a month. That's because of all the interest we're paying. Any questions here? I made up this problem and my husband's name is Ryan and we just got a new countertop and backsplash. So I just made up this number. Ryan funded a new kitchen countertop and backsplash with a $3,400 loan, which he will repay in equal monthly payments over 6 months. The finance charge for the loan was $90. Use the formula to find the finance charge per $100 borrowed, and then use the table to find the approximate APR. So the tables here are just meant to give you an idea of what APR would be typical for a situation like this. There's also online APR calculators. So if you're doing this in practice, you can usually do that, but we'll do it with the table just since that's what our book does and we want to practice that. So you're given this formula, finance charge divided by the amount financed times $100. That's going to give you the amount of money that you are charged in interest for every $100 that you borrow, right? So in this case, it says the finance charge was $90. The amount financed, or the amount that we're borrowing in this case, is $3,400. So I would do 90 divided by 3,400 and then multiply that by $100. Divided by 3,400 times 100. And I get a big decimal 2.647, but I'm just going to round it to the nearest cents. It should be $2.65. So that is the finance charge per $100 borrowed. So this basically means for every $100 we borrow, we're going to have to pay that back plus $2.65 in interest. All right, so we found the first part. The second part is to use the table to find the approximate APR. So first thing we need to do is figure out which row of the table we're looking at, and that's going to be based on the number of payments. So in this case, it said that this was repay in equal monthly payments over 6 months. So in this case, we're only making 6 payments, right? So we're only going to look at this row of the table, this very first row. And then all I need to do here is just look for the number that is closest to the number I found. So $2.65 is what we got. The closest I'm finding to that is pretty close to that is $2.64. And so then I just see what column is that in, whatever column it's in, that's the interest rate. So this is an approximate APR of 9.0%. Any questions? I have 2 problems left that I came up with, and I kind of want to show these at the same time because I purposely, if you look at these, notice they look very similar. And so I purposely made these problems kind of talk about the difference in these so that we could see why do we use a certain formula and when. We look at number 10 here, how much money should Calvin invest now in order to have $50,000 in 4 years if his investment earns 10% interest compounded semi-annually? Number 11 looks really similar. How much money should Calvin invest at the end of every 6 months in order to have $50,000 in 4 years if his investment earns 10% interest compounded semi-annually? So lots of similarities here. How much should he invest in order to have $50,000? So is $50,000, is that a payment amount? Is that a starting amount? Is that how much I want to end up with? In this case, we want to have that amount in 4 years. So that's a future value. And the same thing's going on in number 11. So how much money should we have in order to have $50,000? So I want to end up with that future value. What else is similar? Well, they're both for 4 years. So T is 4 on both of these. Both of them earn 10% interest. So that would be an R value of 0.1 or 0.10, same thing. Both of them are semi-annual. So semi-annual means twice a year. So N would be 2. So if you just like put labels on all these, that by itself is not really enough to go on here because they look pretty much the same, but they're not. So the difference here is number 10 says how much money should Calvin invest now? Versus number 11 says how much money should Calvin invest at the end of every 6 months? So the difference is that this is talking about a starting investment, just putting some money in and saying, what does it grow to, right? Saying, what do I end up with? So this is looking for, the principal is looking for P. Number 11, however, is saying invest every 6 months. So that is a payment, right? That is something that you're going to be putting in at a regular interval, not just a one-time thing. So the difference here is that when it has a payment, that's an annuity, right? So number 11 is going to be one of those annuity formulas. Since there's no payment in number 10 is just going to be compound interest. I'll go through and I'll go ahead and I'll work number 10 and see what we get for that, and then work number 11 and see what we get for that. But I wanted to kind of bring these up at the same time to kind of demonstrate like what is the difference here. Any questions just on that part? All right, so let's go ahead and just going to copy down my compound interest formula. So it's real tempting just to plug in 50,000 per P. Be careful because that's A. So I've got 50,000 equals. I'm going to leave P in there. I'm trying to solve this thing for P. I'm going to go ahead and calculate this part of the formula. Let's see, I could just do that bit by bit. 0.1 divided by 2, that gives me 0.05. So if I add 1 to that, and 1.05, 2 times 4 is really 8. Got what, 50,000 equals P times 1.05 to the 8th power. I'm going to go ahead and raise that to the 8th power. That gives me kind of a huge decimal there. So I'm getting 50,000 equals P times 1.47745544, and I'm assuming that keeps going, but that's as far as my calculator shows. So then if I want to solve this for P, I want to get P by itself, I would divide both sides of this equation by that 1.4774, that big decimal. So since I have that number in my calculator right now, I'm just going to go ahead and type in 50,000 divided by, and then I'm going to use the ANS button. So second negative button. We'll use the ANS button, which will say, hey, I want to divide by that whole decimal without any rounding. If you don't want to use the ANS, just put in as many decimals as you wrote down. So think about this. Should my answer be bigger or smaller than 50,000? Smaller, yeah, because I want to end up with 50,000, which means I would start with a number lower than that, right? So something smaller than 50,000, probably something like 400 is a little too small, right? I probably wouldn't start with an investment as small as $400 and end up with 50,000. So I would expect it's probably some number of thousands. So in this case, I'm getting $33,841.97. So that's how much money I would need to invest now in order to have 50,000 in 4 years. Questions on that one? All right, so let's do number 11. We said annuity formula. So there's 2 annuity formulas to choose from. And again, when it comes to the annuity formulas, if you pick wrong, you can still get the answer right. It doesn't matter, right? So either one will work. Which one would be easier? Well, this one we're looking for R, right? So it makes sense. This one would be a little bit easier, but technically you could use the other one and just solve for R and you'd still get the right answer. But I'm going to go ahead and since I want to find the payment amount, I'm looking for R. I'm going to use that annuity payment formula. All right, so 50,000 was our future value. 0.1 for R, 2 for N. For 4 years. And if you put that in your calculator all at once, in this case, you could go ahead and just say 2 times 4 is 8. But if you didn't do that, extra parentheses around the 2 times 4, and also an extra parentheses around that numerator. So again, anytime you have more than one thing in a numerator, denominator, or exponent, we put an extra parentheses around it. So this number I would not expect to be like 33,000 like number 10 was, because this is a payment amount. This is how much we're going to put in at the end of every 6 months. So I'm not going to put in 33,000 at the end of every 6 months. So I'd expect this to be smaller than that. Still a good amount of money though. I want to end up with 50,000. So putting in a couple hundred is probably not going to do it. Getting $5,236.09. If you're not getting that or you have a question, let me know.
Got it.
That's all the questions that I had prepared. Any other questions?
No, thank you. This has been very helpful.